Today, I will briefly explain the working principle of a shell and tube heat exchanger, one of the most commonly used heat transfer equipment. A shell and tube heat exchanger consists of a bundle of tubes enclosed within a cylindrical shell. Two fluids at different temperatures flow through the exchanger. One fluid passes inside the tubes, while the other flows around the tubes within the shell. These fluids remain physically separated, but exchange heat through the tube walls. As the hot fluid flows through one side, it transfers thermal energy to the colder fluid on the other side. Depending on the application, the flow arrangement can be parallel flow, counterflow, or cross-flow. Counterflow configuration is generally preferred because it provides higher heat transfer efficiency. The main advantage of a shell and tube heat exchanger is its ability to handle high temperatures and pressures while ensuring reliable and efficient heat transfer. It is widely used for heating, cooling, condensation, and evaporation processes. In summary, a shell and tube heat exchanger transfers heat between two fluids efficiently without mixing them, making it a vital component